But first, we're going to talk about what's happening behind the counter. Mark, a 63-year-old man with advanced Parkinson's disease, has regained his ability to walk normally after receiving an electronic spinal implant that interfaces with his brain and restores normal signaling to his leg muscles. The implant, developed by a team of Swiss researchers, is the first of its kind and has the potential to offer a new approach to treating the movement issues Parkinson's patients have. The researchers started by making a super detailed map of the unique structure of Mark's spinal cord, then identified the exact locations in the spine that were involved in walking. Electrodes were implanted at those locations, which stimulate the precise portion of the spine. Mark then wears a movement sensor on each of his legs, and those sensors can tell when Mark has started walking, and the signal for the implant starts to do its thing. The researchers have enrolled 6 more people to attempt to replicate this result before they get to move on to clinical trials. If this is successful, this is a totally novel approach that could have huge implications in treating Parkinson's. Very, very cool, and kind of futuristic sci-fi sort of thing, which is not at all like Christmas. But keeping with that cyborg theme, man and machine interacting, if you haven't heard, Elon Musk has been given permission by the US government to stick microchips in people's brains.
Oh.
Yeah. Yeah. Where's Joey when you need him? Wow. This past summer, Neuralink, a company owned by Mr. Musk, announced that the FDA had granted clearance for the first in-human trials of their BCI, or brain-computer interface. The small coin-sized device is implanted in the brain and records the signals in the brain. It sends those signals to a computer, which translates them into specific intentions, which the computer then sends out to external devices. This effectively allows the patient to control real-world devices with their mind. The company is currently seeking people with spinal cord injuries and lateral sclerosis in the hope that the implant will be able to learn what brain pattern are things like walking and send those signals past the damaged tissue down to otherwise functional limbs to enable these people to regain control of their limbs. The potential applications are literally the stuff of science fiction, restoring sight to the blind, hearing to the deaf, and full mobility to those without it. Of course, Elon Musk didn't stop there. He also suggested that people with fully functioning bodies will want this to enable them instantaneous control over things like phones and computers. Personally, I'm hoping that we haven't gotten that addicted to efficiency quite yet. Joey's a big fan of Elon's. Do you know if he's signed up for the Neuralink beta test yet?
I wouldn't be surprised.
Oh, come on. He wouldn't do that. That's insane. Would you do that? Assuming that you've been injured in some debilitating accident, would you be open to having an implant put in your brain to help you potentially move again?
Yeah, I don't have any real academic understanding of this.
Yeah.
But as, you know, just an everyday person, it's an intriguing idea.
It is.
I would say that this sounds pretty good. I mean,
it's
at least worth a shot.
What's bizarre is if you go to the website, you can see this stuff, because of course they test this on animals before they ever test it on a human. There is a monkey playing Pong with his brain on their website, because that's the first thing is they taught the monkey how to control a cursor on a screen or the paddle with his brain. And so the researchers are playing Pong with the monkey, and the monkey is just thinking where he wants the paddle to go. It's bizarre.
That's pretty wild. What's interesting is like the first article you shared about the Parkinson's implant. We're like, wow, this is like great. This is great. But we're talking about a similar implant, but because it's with Elon Musk.
Yeah.
And we're like, oh,
well, the difference
about that.
The difference is the Parkinson's one, they implant it, I believe, on the spine. And it because of the way Parkinson's works, I think it sends your brain is sending erroneous signals down the spine, which is causing the instability and the fidgety movement and that sort of thing. And the implant, what it functionally does is actually interrupt those signals. Mm-hmm. This is the opposite of that. This is going further, and instead of implanting it lower on the spine, they're implanting it directly in your brain.
But it's to help people with mobility issues.
That's where we start. But eventually he just wants you to be able to surf the net with your brain. So you can drive your Tesla with your mind.
Yeah.
So, well, to your question,
I like it.
your question that you asked Dante about if he were to experience, God forbid, debilitating injury, would he do it? I think you'd have to be open to it.
Yeah.
I mean, it's the same thing with like, being an organ donor or not.
Novel cancer treatments and trials. And
I've heard Elon compare this to using glasses, that if your eyes don't focus properly, you put on glasses, and that's the same thing. If your spine doesn't communicate the signals down to your feet properly, then you put on a neural link. I don't know. It's not my thing.